Okay, let me share the screen first. Okay, welcome everyone to today's session. So last class we discussed sort of machine learning, right? The role of machine learning in data science. We came across 3 ML algorithms for data science that we will discuss as we progress. The first one was regression. Having a little discussion on AI, we went to ML, right? AI has other inclusions, but here is our main focus, right? ML. And we sort of discussed the supervised one and the unsupervised ones. Of supervised, I'll make you cover regression and classification. And for unsupervised, we will have a look at clustering, clustering algorithms. Now, for this regression, we have linear. We do have nonlinear regression as well. Now, of these linear ones, our primary focus is on linear regression. And I told you yesterday, we have again 2 categories of it. One simple linear regression and a multiple linear regression. So when I say simple linear regression, I mean to say the condition where you have one dependent variable and one independent variable, right? And when we talk of multiple linear regression, meaning we have one dependent variable and 2 more than 2 independent variables, right? This way. So this situation calls for multiple linear regression and this one for simple linear regression. So when we say we deal with simple linear regression, meaning we are assuming that the independent and the dependent variables, they share a linear relationship, right? That is the prime requirement. At least that requirement has to be fulfilled. Fitting a linear line to almost non-linear data doesn't make sense. So if we are aiming to fit a simple linear regression for a data set, which is having one target variable and one feature variable, this indicates that you are assuming that they are varying linearly in the space, right? Linearly in this space, whatever the data is. As I told you yesterday, we will deal with some mathematical thing here. I will try to make it more conceptual. So before going into this, to this scenario, let us just brush up few simple things. Suppose here is your scenario. You have a data set with data points such that for 1 unit change in X, the corresponding change in Y is also 1 unit. Suppose. So that when X has value 1, Y shows 1. When X has value 2, Y shows 2. X has value 5, Y shows 5. A very perfect situation. So if you have data set where the values follow such relationship, this is sort of ideal condition, right? We can easily make a straight line pass through these points, is it? This one. How do you represent this straight line? Can you tell me, how do you represent this straight line?
Like y is equal to mx plus c.
Yes, that would be very general one. No? For this one, particularly for this one,
Y is equal to mx.
that is again a generalized one. For this one particularly, it will be?
Yeah, x is equal to y.
B1 x.
Yes.
B not.
It's y equal to x, right? When x is 1, y is 1, no? When x is 2, y is 2.
Yes.
When x is 5, y is 5, right? That means y is equal to x. This is the most simplest condition for any linear relationship, y equal to x. Now for this y equal to x, now this plus, now right? For any line which is parallel to this one, suppose this. Let me make it this. How will you represent this one? Suppose in the same space, you have data points and you can make a straight line passing through those data points this way. And suppose this is parallel to this one. How do you represent this line?
X plus 2.
Yes, y equals
X minus 2 plus 2.
Plus 2. Why?
Because 2 is the intercept on the line. This line cuts y on so 2 is the intercept.
Then, meaning when x is 0, y is 2, right? So when x is 0, you are supposed to get y value as 2. So that means you have to have plus 2 in the equation, right? Suppose you have a third data set. And the linear relationship follows this line, this straight line. What do you think will be the equation for this line? Y equals. It's passing through 2, but
Yeah,
now it is not parallel to this. What do you think? How will you represent this straight line?
mx plus 2.
Yes. Now, since you don't know the inclination of this straight line, I have not provided you any information regarding that, right? So it will be y equals mx. But you do know when x is 0, y has value 2. So plus 2 is known. So that equation will be represented by y equals mx plus 2, where m denotes the factor by which this line is getting inclined, right?
Slope.
When y is what? Yes, actually this term, the coefficient of x actually gives the information regarding the slope of the line. When we say slope, what does it mean? Slope means, what is the meaning of slope? If somebody asks, will you describe what is slope?
How y changes with small change of x.
Yeah, for unit change in x, what is the change in y that you observe is the slope, right? That is the physical interpretation of it. For a unit change in y, x, what is the corresponding change in y? Now, since in this green case, for unit change in x, there is unit change in y. That is why the coefficient is 1, right? So slope indicates that rate. Meaning it actually indicates dy by dx. Can we say? Rate of change in y, that is slope, right? A unit change in x, what is the corresponding change that is getting reflected in y? Or in terms of trigonometry also you can explain, is not it? Slope in a way tells you the inclination of this straight line with the horizontal axis, is not it? If this angle is theta, then slope indicates tangent of this theta. Is it? Can we say? How do you find, how do you relate this tan theta here in this figure?